Hi everyone, welcome. This is Desi Vijay. I'm a North-South national team member and a coordinator for the webinars. Glad to see you all here today. This is a very unique session in which accomplished math-savvy high schoolers are going to solve this year's AMC 10 problems live, just in front of you. Back in November 2020, we offered a similar session for AMC 8. Since the problems today are going to be a little bit more tedious and might take more time, we have broken this up into two different sessions. First session today, we'll attempt the problems 1 to 15, and we'll have a session 2 on Sunday at 4:30 p.m. for the rest of the problems. Our intent here is to mainly motivate our kids to be more interested in math and look beyond our North-South contest into national and international competitions. So we'll welcome you all, and this very idea of the session was conceived by volunteers of the NSF and Me initiative, NSF Math and Me initiative, and I'm really glad we are able to do it today. Now we will start moving to the regularly scheduled program. I'm glad to have Vivek Velurapalli, who diligently planned and organized these two sessions. He is a high school sophomore and has been participating in competitive maths competitions for the past 9 years. He has qualified for the AAME Invitational Competition twice, along with being in the AMC 10 Distinguished Honor Roll. He has gone to the North-South Math National Finals 5 times and is a long-time North-South student volunteer. He has really worked very hard along with the active members of the NSF Math and Me group initiative to make this session happen. We thank him for that. Without any further ado, it's my pleasure to invite Vivek to introduce our other panel members and the parent volunteers, and then guide us through the live presentation. Here is Vivek.
Hello, welcome to the AMC 10 Problem Seminar. Problem solving along with me today is Krish and Ram. Krish has qualified for Math Counts Nationals, and Ram has gotten Distinguished Honor Roll from AMC 8. So we have two strong math students alongside with me. Also, thank you to the parent volunteers behind the scenes making this hopefully be a success.
I have my screen, the presentation you want to go through now, right?
Yeah.
Okay. So here is a quick overview of what we are going to accomplish today. And go ahead, Vivek.
So this is a quick presentation for those who may not be familiar with the AMC competitions and this whole system that's there. So next slide, please. So the MAA, which is the Mathematical Association of America, is the organization that runs these AMC, AIME competitions. All of these are grouped together by the same people. The competitions keep getting harder and harder until the United States IMO, which is the International Math Olympiad team, is selected. Next slide. So here is the general funnel from easiest test to hardest test. So you see at the very beginning, we have AMC 10 and 12, which is what we're going over today. And if you do very well on that, you can get invited to the AIME, which is the next test. And it goes so on until USAJMO, MOP, and IMO. Today, we'll only be going over AMC 10/12 and AIME and what they are about. But if you would like to learn more about this whole process, just go to maa.com. So the AMC 10 is a 25 problem, 75-minute exam. There are two separate tests, the AMC 10A and the AMC 10B, each with different questions, and students can take both. Today, we'll be going over the 2021 AMC 10A, problems 1 to 15. Generally, in the AMC 10, the first 10 questions are easier problems, while as they go on to the later ones, they become harder. Students in 10th grade and younger are allowed to take this test, and students with higher scores can qualify for the AIME, which is the next level of competition. There's also a harder variant of the AMC 10, which is called the AMC 12. with harder questions, this is for 12th graders and younger, meaning that anyone who takes the AMC 10 can also take the AMC 12 if they would like. Next slide. The AIME is the next level of math competitions from the MAA. It's a 15-problem, 3-hour test, which is designed to be much harder. Students with a high combined score on the AMC 10/12 and AIME can qualify for the next level of competitions called the USAJMO and USAMO, depending on the combination of tests taken. Again, if you would like to learn more, just visit https://www.maa.org.
So
All
who is
right.
going to?
This is Ram. I will be discussing problems 1 through 5 with you guys. So we can start with problem 1. What is the value of open parentheses 2 squared minus 2 minus open parentheses 3 squared minus 3 close parentheses plus open parentheses 4 squared minus 4? So this problem is pretty straightforward. We can calculate what is the value of each group of parentheses. So the first one is just 2 squared minus 2, which is 4 minus 2, which is 2.
Are you able to use it?
Yes.
Okay.
The second group is 3 squared minus 3, which is 9 minus 3, 6, plus 4 squared minus 4, which is 16 minus 4, which is 12. This gives us 8. So our answer for problem 1 is D. This problem is pretty straightforward. You could, just knowing basic PEMDAS, you could do this. Okay, we can move on to the second one.
Okay. So let's go to that problem 2.
Portia's high school has 3 times as many students as Lara's high school. The two high schools have a total of 2,600 students. How many students does Portia's high school have? So for this problem, we can just let the number of students in Portia's high school be P, and the number of students in Lara's high school be L. So we know that the total number of students is 2,600, so that means P plus L is equal to 2,600. Since the number of students in Portia's high school is 3 times the number of students in Lara's high school, we also get that P equals 3L. We can substitute this equation into the first. So we get 3L plus L equals 2,600. So 4L equals 2,600. This means that the number of students in Lara's high school is 650. We are asked to find the number of students in Portia's high school. We can use the second equation to find this. So we already know what L is, 650. So that means the number of students in Portia's high school is 3L, which is 3 times 650, or 1950. So our answer is C.
Great. You guys were monitoring the questions, right? If there's anything, let me know. Okay, let's go move on to the third problem.
The sum of two natural numbers is 17,402. One of the two numbers is divisible by 10. If the units digit of that number is erased, the other number is obtained. What is the difference of these two numbers? So the key thing to note that is the first number, we'll call the two numbers A and B. Since the first number is divisible by 10, it ends in at least 1 0. So we can write the first number as a string of numbers followed by 0. Now we know that the second number is just the first number, and we erase this units digit. So since we're erasing the 0, that's the equivalent of dividing by 10. That means we can say the first number A divided by 10 equals B, or in other words, A equals 10B. So we know that the sum of these two numbers, A plus B, equals 17,402. So A plus B, 17,402. We can substitute the value of 10B here. So 10B plus B equals 17,402. So we get that 11B is 17,402. or we get that B is just 1582. So we are asked for the difference of these two numbers. So that's just the same thing as the absolute value of A minus B. A is the same as 10B. So that means this is just 10B, absolute value of 10B minus B, which is just 9B. We can use the value of B here, 1582. So 9 times B, which comes out to be 14,238. So our answer is D. Alternatively, you could have noticed that since A ends in a 0, we can move on to the next slide. I'll need a little bit of space. So we know that A ends in a 0. So and B is just A and then A divided by 10. So it's just without the 0. The sum of these two numbers is 17,402. Since the units digit of A is 0 and the units digit of 17,402 is 2, we get the units digit of B is 2. So that means, and we found out our difference to be equal to 9B. Since the units digit of B is 2, we must have that our number ends in an 8. The only answer choice that ends in an 8 would be D. So our answer choice would be D.
So there is a question, Ram, from the audience. How do we generally approach these problems when seeing it in a competition?
So for this, I think if you just know that it's divisible by 10, you could immediately say that it ends in a 0. And since you're erasing that 0 to get the second number, you're just dividing it by 10. So you could immediately calculate A equals 10B, and you would get 11B equals the sum. You don't really need to do anything too complicated here. Just use what's the information that's given to you. I hope
Good.
that answers your question.
So move on to problem 4.
So a cart rolls down a hill, traveling 5 inches in the first second and accelerating so that during each successive 1 second time interval, it travels 7 inches more than during the previous 1 second time interval. The cart takes 30 seconds to reach the bottom of the hill. How far in inches does it travel? So in the first second, it travels 5 inches. Then in the second 1 second time interval, it will travel 5 plus 7 inches. In the third, they'll travel 5 plus 7 into 2, which is 7 more. And so on. And this will go on for 30 successive time intervals. So the total distance that the cart travels is just the same as the sum of these 30 values. And if you notice, this is just an arithmetic sequence with 30 terms. We can write this arithmetic sequence as a sub n, the nth, which is the nth term, is 5, our initial term, plus 7 times n minus 1. 7 is our common difference. So we are asked to find the sum of the terms a1 plus a2 all the way till a sub 30. Since we have, it takes 30 seconds for the cart to reach the bottom of the hill. So we know that this is just 5 plus 7. We can call this sum S. So S equals 5 plus 7, and then 5 plus 7 and 2, all the way till the 30th term. The 30th term is just 5 plus 7 into 30 minus 1, which is 5 plus 7 into 29. So how can we find the sum? So let us okay, let's first calculate what this is. 5 plus 7 into 29 is 208. So we can rewrite the sum backwards. So let's reverse all of this. The last term is 208. The previous term will be 7 less than that, since we're going backwards. So this will be 208 minus 7 plus 208 minus 7 into 2, all the way till 5. So let me put this on the next slide. Can we go to the next slide quickly?
Yeah.
So we wrote our sum like this, all the way till 208. And then we write it backwards. S equals 208 plus 208 minus 7, all the way till 5. So notice what happens when you add these two equations. You get, on the left-hand side, you get 2s. The first term is 213. The second term, this positive 7 and minus 7 cancels out. So you're just left with 213. The second term, let me just write it here, 5 plus 7 into 2. And this is 208 minus 7 into 2. This 7 into 2 will again cancel, so you get 213. And this will happen for 30 terms. So on the left, you're just left with 213. So it's just 2s equals 213 times 30. This we can quickly calculate. 2s equals 6390. So our sum, which is our total distance, is 3195. So our answer is D. If you remember this, also if you just remember the sum of an arithmetic sequence formula, which is just the first term plus the last term divided by 2 times the number of terms, you could you can use this formula and you can get the same answer because the number of terms is 30. Our first term is 5. Our last term is 208 divided by 2 times 30 terms. This will give you the same answer, 3195.
Ram, there are a couple of questions. So one question asks, could you have just found the average of the first and the last term?
Yes, that's essentially what this formula is saying. You have the first average of the first and last terms times the number of terms.
There's a
So
second. Sorry, go ahead.
Go ahead. So yeah, it's just here, this is average of first and last, which is 213 divided by 2 times number of terms is 30. So that will also give you 3195.
One of the audience members would like you to go over it once more, really quick. Felt that they didn't understand. So maybe you can, just quickly.
Which part specifically did they not understand? Or I can just go over it.
Yeah, just go over it.
Yeah. So the cart rolls down 5 inches during the first second. Then in each successive second, it goes 7 more inches. So 5, and it takes 30 seconds to reach the bottom of the hill. That means we'll have 30 successive time intervals. So we'll have 5. That means in the first time interval, it'll go 5 seconds. In the second time interval, it'll go 5 plus 7 seconds because it's traveling 7 inches more. In the third time interval, it'll go 5 plus 7 into 2 because you're adding 7 each successive time interval. So this is just a sum of an arithmetic sequence. So we can write the arithmetic sequence. We can write each term of the arithmetic sequence as a sub n, where a is the n is the number of the term. So we can just write this as 5 plus 7 times n minus 1. So the first term would be 5 plus 7 into 0, second term 5 plus 7 into 1, and so on until we have our 30th term, since we have 30 successive time intervals. So that means the total distance traveled is the sum of the distance traveled in each time interval. So we just need to find A1 plus A2 all the way till A sub 30. So A1 is 5, A2 is 5 plus 7, A3 is 5 plus 7 into 2, all the way till A sub 30, which is 5 plus 7 into 29, which is 208. So to quickly find the sum of this, you can just reverse this sequence. So you can start with the last term and go to the first term. You could start with 208 and then 208 minus 7, since you're going backwards by 7 inches instead of adding 7. So 208 minus 7, then 208 minus 7, which is 208 minus 7 into 2, all the way till 5. So if we can go to the next slide.
Ram, so
Yes.
there's a request. Can you please slow down?
Okay. So we could so we have on the first time interval it goes 5 seconds. On the second time interval it goes 5 plus 7 seconds because it goes 5 seconds 7 inches further. On the third time interval it goes 7 inches further than that, which is 5 plus 7 plus 7, or 5 plus 7 into 2. This goes all the way until 5 plus 7 into 29, because there are 36 30 1 second time intervals. So we have 5. The total distance traveled is the sum of the distances traveled in each time interval. So that would be 5 plus 5 plus 7 plus 5 plus 7 plus 2, all the way till 5 plus 7 into 29. So this last term is 208. We can, to find the sum quickly, we can reverse this sequence. 208 is the last term. Then since we were adding to get to 208, we can subtract to get to 5, which is basically reversing this sequence. 208. So the second term would be 208 minus 7. Then 208 minus 7 into 2, all the way till 5. Now, if you notice, when you add these sequences, you get on the left-hand side 2s. And on the right-hand side, 5 plus 208 is 213. Then the second term, 5 plus 7, and 208 minus 7. When you add these two, the positive 7 and negative 7 cancels out. So you have 213. Third term, 5 plus 7 into 2, and 208 minus 7 into 2. The 7 into 2 cancels out. So you again get 213. And this goes all the way for each time interval. So you'll have 30 time intervals. So you'll have 213, adding 213 30 times. So which means 2 times the sum, which is our total distance, is 213 times 30, or 2s equals 6390. So our total distance is 3195.
Can go.
There's a question, sorry, still on the previous one. Why did you do times 29 instead of 30, since there are 30 time intervals?
So notice that on the first time interval, we are only going 5. We are not at, so okay, let me write it down here. On the first time interval, we are going 5 inches. On the second time interval, we are going 5 plus 7. On the third time interval, we are going 5 plus 7 into 2. So notice that this is just 5 plus 7 into 0, 5 plus 7 into 1. We do not add 7 on the first term. So that's why we're only going from 0 to 29 instead of 1 to 30. So our last term is going to be 5 plus 7 into 29.
Thank you. You can move on.
Okay, problem 5. The quiz scores of a class with K greater than 12 students have a mean of 8. The mean of a collection of 12 of these quiz scores is 14. What is the mean of the remaining quiz scores in terms of K? So we have K quiz scores. 12 of them have an average of 14. Average of these is 14, which is average is the same thing as mean. For the remaining, so we have a total of K students. That means the remaining is K minus 12 students. We are asked to find the average here. We'll call this average A. So the key thing to note is that average is the same as the number, sum of the terms divided by the number of terms. Average. We can rewrite this to say that the sum of the quiz scores is the average of the quiz scores times the number of quiz scores. We can use this for all 3 sections. So for this one, we can use this formula for this these 3 sections to write them in terms of K. So the first one, we have since there are 12 quiz scores and the average is 14, our sum is going to be 12 times 14, which is 168. For our second one, which is there are K minus 12 quiz scores, and the average is we're going to find out. We're going to call that A. So the sum of these scores is K minus 12 times A, and the sum of all of them is there are K quiz scores and there's a mean of 8. So that means the sum of all of them is 8 times K. Now we can equate these two. So 8K, which is the sum of all quiz scores, is equal to 168 plus K minus 12 into A. We can subtract 168 from both sides and divide by K minus 12. So 8K minus 168 divided by K minus 12 equals A. So our average of these remaining quiz scores is 8K minus 168 over K minus 12. So our answer is B.
There's a question, how did you get 8K? Maybe you can explain that part a little again.
Oh, so we have a mean of 8. There are K students. And we have a mean of 8. So that means the sum of the quiz scores is the average times the number of quiz scores, which is 8 times K.
So there is a question
You can
about
move on.
what is sum divided by what?
Oh, sorry. This is sum divided by number of terms. Here our terms are just the quiz scores. Let me write that a little bit more neatly.
Can you really quickly repeat the process? I think there are several people who are asking if you can just go over it once more, a little slowly.
Sure. So we have K students. They have a mean of 8. A collection of 12 of these have an average of 14. So what is the mean of the remaining quiz scores? So we can draw this as we have a total of K students. 12 of them have an average of 14. And the remaining since there are a total of K students, there are remaining K minus 12 students. We are trying to figure out the average of these K minus 12 students. We'll call this average A. So what is the definition of average? Average is the sum of the terms divided by the number of terms. Here our terms are quiz scores. So we can rewrite this as the sum of the terms equals average times the number of terms. So this so we can apply this to all like 3 subsections. So we can apply this to the 12 students. The 12 students, they have an average score of 14. So the sum of their quiz scores is 168. On over here, since there are K minus 12 students, and their average score, we were trying to figure out, we are calling that A. The sum of their quiz scores is K minus 12 times A. And for everybody, there are K students and they have a mean of 8. So the sum of their everybody's scores is 8K. So since there are K students and we have split them up, we can equate these two. This 8K is equal to 168 plus K minus 12 times A. These are basically just, we have just basically split the sum of this quiz scores into 2 sections. So so 8K equals 168 minus plus K minus 12 times A. We can subtract 168 from both sides and divide by K minus 12. So we get the average of the remaining K minus 12 students is 8K minus 168 over K minus 12.
Go to the next page, or you're okay?
I think that's it for me.
Okay.
I think you can move on.
Thank you, Ram. And then
Hello, so I am Krish, and I will be working on with you guys on questions 6 to 10. So question 6 is, Chantal and Jean start hiking from a trail toward a fire tower. Jean is wearing a heavy backpack and walks slower. Chantal starts walking at 4 miles per hour. Halfway to the tower, the trail becomes really steep, and Chantal slows down to 2 miles per hour. After reaching the tower, she immediately turns around and descends the steep part of the trail at 3 miles per hour. She meets Jean at the halfway point. What was Jean's average speed in miles per hour until they meet? So we have something like this. So this is the halfway point. And so Chantal walks all the way here and then goes to steep part and then back down. So Jean only walks to the halfway point in the same amount of time than Chantal takes to walk to the halfway point, up and then back down. So we want their times to be equal. We can use this formula. Distance equals rate times time. Because we specifically want to find time, we can let time equal distance over rate. So now we just add up the time that Chantal takes to get back to the halfway point. First, she walks a distance of d, which is just the distance to get to the halfway point. She walks at 4 miles per hour. Then she goes at 2 miles per hour, that same distance, and then back at 3 miles per hour, back down. This is equal to the same amount of time that Jean takes to get to this distance. Because we want to find the speed or the rate that she takes, we can just let this be x. So can you reuse the next slide? So what we can do is divide everything by d. So we have 1/4 plus 1/3 plus 1/2 equals 1 over x. Adding up these fractions, we get 13 over 12 is equal to 1 over x. And then if we flip them, we get x, which is her Jean's speed, is equal to 12 over 13. So the answer is A.
Question, why would you put D is equal to 1?
No. So what I did is, let me rewrite it. I had D everywhere. And then what I did was I divided everything by 1, by D. So here I would get a 1. Here, dividing by D gets me a 1. Dividing by D gives me 1 everywhere. And because D is not equal to 0, we can divide by D.
Another question is, why did you flip 13 by 12 to 12 by 13? Maybe you can explain that process of the reciprocal process here.
Yeah. So what happens is we have 1 over x. And because we want to solve for x, we can either flip it, which you might not know, or what I will do is if I multiply both sides by 12 times x, I get 13x is equal to 12. So x is equal to, dividing by 13 gives me 12 over 13, which is just flipping both sides.
Thank you. Maybe you can just go over it once more, because there are a number of questions around how did you get the fractions 1/4, half, 1/3. And one question is x the average rate of Chantal? So maybe you just can go over that, over the solution once more real quick.
Okay, can you go back to the, yes, okay.
Yeah, this is the first one. Yeah.
So we have that Chantal walks to halfway point, up and then back down. So we want the time of Chantal to walk back to the halfway point to be equal to the time of Jean just to get to the halfway point. So we can use this equation, distance equals rate times time. Because we want to find the time, we can just say time is equal to distance over rate. So now we add up Chantal's side, which we did on the left. First, Chantal walks at a speed of 4 miles per hour, so we have D over 4. Then Chantal walks at a speed of 2 miles per hour, so we have D over 2. And then Chantal walks at a speed of 3 miles per hour, so we have D over 3. This time that Chantal takes is equal to the time Jean takes to get to the halfway point. That distance is D, and we want to find the average speed. So we just let the average speed be x. We have the right-hand side, D over x. And then we just, can you go to the next slide? We divided everything by D to get 1/4 plus 1/3 plus 1/2 plus is equal to 1x. Adding up the left-hand side, we get 13 over 12 is equal to 1 over x. So x is equal to 12/13.
So there's a question, how do you know that 2 times Chantal and Jean are equal?
Wait, can you say that again?
Yeah, I didn't quite understand the question also. I will clarify that. I think there's a general question around how you set up that first equation, the D by 4 plus D by, I think if you can go over the process, you're thinking around, how did you set up that equation?
Yes. Okay. So basically, Chantal takes time, a certain amount of time to get to the halfway point, then back up and then back down. So we can just let it be T1 plus T2 plus T3. Now, we are given the Chantal meets Jean back at the halfway point, right after she comes back down. So this means that Jean takes a certain amount of time to get to the halfway point, and by that time, Chantal has already walked to the halfway point, up and then back down. So this time is equal to the time that Jean takes just to get to the halfway point. Now, we have 4 variables here, but we're given, we can use the d equals rate times time. Because we are given the rate, which is at first 4 miles per hour, then 2 miles per hour, then 3 miles per hour, we can set this equation up. We just let d be equal to the distance to get to the halfway point, and then we can let x be the speed of Gene, the average speed of Gene to the halfway point. Does that clarify it?
Yeah, I suppose. Another question is, how did you add up three fractions with different denominators so fast? So tell them your tricks.
Well, 4 times 3 times 2, right? So the greatest, no, not the greatest, the least common multiple of them is just 12. So 12 divided by 4 equals 3, and then 12 divided by 3 equals 4, so 4 plus 3 is 7, and then 12 divided by 2 is 6. So we have 7 plus 6, which is the 13, which is the numerator. And then the LCM, which is the denominator, which is 12.
Thank you. Go ahead.
All right. So this one, we have Tom has a collection of 13 snakes, 4 of which are purple and 5 of which are happy. He knows that all of his happy snakes can add, none of his happy snakes can subtract, all of his snakes that can't subtract also can't add. Which of these conclusions can be drawn about Tom's snakes? So this is like a logic problem, and the best way to do this is just read all the answers and see if they make sense, if we can say that that is true. So the first one is purple snakes can add. It says that no purple snakes can subtract. And if a snake can't subtract, it also can't add. So purple snakes cannot add. So that one is not the answer. The second one is purple snakes are happy. If a purple snake is happy, then that purple snake must be able to add, because it says all of its happy snakes can add. However, we just said that purple snakes cannot add. That was why we crossed out A. So purple snakes are not happy. C, snakes that can add are purple. Because we said purple snakes can add, if a snake that can add is purple, it must be able to add. And because purple snakes cannot add, snakes that can add cannot be purple. So C is not the answer. D, happy snakes are not purple. Because happy snakes can add and purple snakes cannot add, happy snakes cannot be purple. So this one does work. However, it's always good to read the final answer to just make sure that it doesn't work. So the last answer is happy snakes can't subtract. Because happy snakes can add, it says that all the snakes that can't subtract also can't add. Because that means if a snake can add, it should be able to subtract. Because if it can't subtract, it can't add. This means that happy snakes can subtract, because then because we already said that it can add, and if it can add, it should be able to subtract. So the answer is just D. Happy snakes are not purple.
Thank you. One quick question was, how did you rule out A by determining that snakes that can't add can't subtract?
Okay, so it says in the second one that none of his purple snakes can subtract. And then it says that snakes that can't subtract also can't add, which means that none of his purple snakes can add, which means purple snakes cannot add.
Thank you. Go ahead. I would like to announce that there are a lot of questions around the recording for the session. So there will be a recording, and that recording will be put on the NSF YouTube channel. So anyone who finds it too fast to follow or would like to see the problem solving process once again, can then look at the recording at their leisure.
Yeah.
Thank you.
And also we will be sending them my email with the link tomorrow, so they can look at it either through webinar or through YouTube. So can we go to the next problem?
So should I do it?
Yeah, go ahead.
Okay. So the question 8 is, when a student multiplied the number 66 by the repeating decimal 1.AB, going on forever, where A and B are digits, he did not notice the notation and just multiplied 66 times 1.AB. Later, he found that his answer is 0.5 less than the correct answer. What is the two-digit integer AB? So here we need to know this. Any repeating decimal, this is just repeating AB on forever, we can put it into fractional form like this, AB over 99. And if it was 3 digits, we would just have 999 and going on like that. So we could set this equation up. So first, a student multiplies 66 by this repeating decimal. And because it's 1 point, the repeating decimal, we just simply add a 1 in front of it. And we know that this answer is 0.5 greater than the incorrect answer that he had. So we can say it's half plus 66 times 1.AB. 1.AB is just AB over 100 plus 1. Can we use the next slide, please? So now what we can do, let me just rewrite it real quick. This is our equation that we have. What we can do now is we can multiply everything by, or divide everything by 66, or we could expand everything. What I'm going to do right now is I'm going to expand everything. So I have 66 plus 2AB over 3 is equal to 1/2 plus 66 plus 33AB over 50. So here we see that we have 66 on both sides. So I'm just going to get rid of the 66 because we have them on both sides. Now I'm going to just make the right hand side better by making it into one fraction. So I have this 33AB plus 25 over 50. Now what I want to do is I'm just going to multiply both sides by 150 to get rid of these fractions. So then we have 100 AB is equal to 99 AB plus 75. So bringing the 99 AB to the other side, we have AB is equal to 75. So the answer is E, 75.
Thank you. I think the overall, they would like to have you sort of repeat it once more, a bit slowly. And
Okay.
overall, for both of you panelists, if you can take a bit more time when you set up the equation at the beginning, right? Not so much when you're solving it at the end, but at the beginning when you are setting up the equation. If you can take, if you do it slowly and explain it a little more, I think it will be very valuable.
Yes, okay. So can you go back to the slide? Can you go to the first slide, please? Okay. So first we have this idea. So point AB going on forever is just equal to AB over 99. So we could set everything up into fractional form. Now, we notice that what he does is he's going to multiply 66 times 1 point AB, which is just AB over 100 plus 1. And this answer that he gets is 0.5 less than the correct answer. So we're going to add 1/2 to it, which is just 0.5. That's how we get the right hand side. The correct answer is just 66 times the repeating decimal. So we have 66 times AB over 99. And because there's a 1 in front of it, we just add a 1 to it. So we have this equation. Now can you go to the next slide? So now what we just do is we can expand both sides by multiplying the 66 out. So what we end up getting is 66 plus 2AB over 3 is equal to 1/2 plus 66 plus 33AB over 50. Now, we have 66 on both sides, so we can just subtract the 66. We can get rid of them all. Now we just have a simple equation that we need to solve. So we can get the both of these fractions on the right hand side onto one fraction. That's just done by changing the 1/2 into a 25 over 50 and then adding it. So we have 2AB over 3 is equal to 33AB plus 25 over 50. Now what we can do is we see that the least common multiple of 3 and 50 is 150. So if we multiply both sides by 150, we end up getting 100AB is equal to 99AB plus 75. If I bring the 99AB to the other side, I just simply get an AB. So I get AB is equal to 75. Does that clarify it?
Yes. There are questions like, why did you add half on the right side?
Yes. So it says that his answer that he got, the 66 times 1 plus AB over 100, is 0.5 less than the correct answer. The correct answer is 66 times 1 point AB over 99. Because the answer that he got, which is wrong, is half less than the correct answer. If I add 1/2 to it, I should be able to get the correct answer. And then I can just have this equal sign and then solve for AB.
Thank you. You can move on.
Okay. So 9. What is the least possible value of parentheses xy minus 1 parentheses closed squared plus parentheses x plus y parentheses squared for real numbers x and y? So what we can do here is we can expand this whole expression. So we can use this idea. A plus b squared is just equal to a squared plus 2ab plus b squared. So now we can expand the first term to get x squared y squared minus 2xy plus 1. Now we expand the second term to get x squared plus 2xy plus y squared. Now, because we have a plus 2xy and a minus 2xy, they both cancel each other out. So we get rid of the 2xy's. Now we have x squared y squared plus 1 plus x squared plus y squared. Now here's one important thing we need to know. All perfect squares or all squares are always going to be greater than or equal to 0 because they cannot be a negative answer. Like -7 squared is 49 and 5 squared is 25. They're like both greater than or equal to 0. And the only case that it's equal to 0 is when the thing that is being squared, so if we had x squared, the only case when x squared is equal to 0 is when x is 0. So what we would love is if this could just be 0, then we have a +1. The x squared could just be a 0, and the y squared could just be a 0. In this case, the answer would be 1. And if we just let x be equal to 0, which is how we get that, we see that x squared y squared is also 0. So this is possible. This is the least possible value. So then we just have 0 plus 1 plus 0 plus 1, which is equal to 1, which is the answer is D.
Yes.
One small suggestion, Krish, instead of erasing it, can you just strike it off so people have the continuity of what went on?
Okay, let me do that real quick.
That's fine. Yeah. Yeah.
Are there any questions?
Can you explain the last part again? A
Okay.
couple of people have asked.
So we have, if we expand it, we get x squared y squared minus 2xy plus 1 plus x squared plus 2xy plus y squared. The 2xy's just cancel. So we have 3 perfect squares and then a +1. Now, all perfect squares are greater than or equal to 0. They cannot be a negative number if the term is real. Now, if it is equal to 0, then whatever we're squaring, suppose it's x squared, x would then have to be equal to 0. So the least possible value of a square is 0 if the term being squared is 0. So we would like is if the x squared y squared is 0, the x squared is 0, and the y squared is 0. That would give us what we would love to be the least possible value. And we can see that x, y, if both of them are 0, then x squared y squared is also equal to 0. So then it is possible for all 3 of the perfect squares to be equal to 0. So we have this +1 still. 0 plus 1 plus 0 plus 0 is simply equal to 1.
There are a number of small questions like if x and y are different, how can they both be 0? I'll just read out all the bunch of questions together so you can answer it as you. Why did you cross out 2xy? I don't understand how he expanded the equation. So maybe, if you take the original equation, the question, if you can probably, a couple of steps more, if you can show,
Okay.
that would be useful. Yeah.
So those 3 questions?
Yeah.
Okay. So the first or one question was, how did I get this expanded term, I guess. So can you go to the next slide, please? So we have this expression, right? And we can say this if we're squaring a plus b, it equates to a squared plus 2ab plus b squared. This is a fact that we know. So we can use this. So doing the first one, the xy minus 1 squared. Yeah. First, we let a be equal to xy and b equal to 1. So first what we have to do is we have to square a. In this case, just squaring xy. Then the second is to multiply AB. In this case, we just multiply xy with -1. And then the final one is just to square B. So if we square -1, this equates to x squared y squared minus 2xy plus 1. And then for the x plus y squared, we can just, instead of having a and b, have x and y. So we would have x plus y squared, just copying this formula, instead of having an a, having an x, plus 2xy plus y squared. And can you go back to the previous slide? So another question was, why do we cross out the 2xy? And it's because we have negative 2xy plus 2xy. So we suppose we had -5 and +5. If we add these two, we get 0 because both of these are just the -1 version of each other. So doing the same thing here, we have -2xy plus 2xy. We can just cross them out because they're both the same value. Just one of them is the negative version of the other. Is there any other questions?
So there's one question which I didn't quite understand. So 0 to the power of 2 is equal to 1. So what is x in the equation, in the fact x to the power of 2 is equal to 0?
Okay, 0 to the 1 is not equal to 1. That is 1 to the 0. 0 to the 1, 0 squared, they're all equal to 0. It's just 1 to the 0, which is equal to 1. Or actually, I can say a to the 0, if a is not 0, is equal to 1. But 0 to a is equal to 0. So 0 to the any power is always equal to 0. But a number raised to the 0 power is equal to 1.
Thank you. I think you can move on.
Okay. So the question 10. Which of the following is equivalent to 2 plus 3 times 2 squared plus 3 squared times 2 to the 4th plus 3 to the 4th times 2 to the 8th plus 3 to the 8th times 2 to the 16th plus 3 to the 16th times 2 to the 32 plus 3 to the 32 times 2 to the 64th plus 3 to the 64th. So we see here that because the first term is just the exponents are 1, that the exponent doubles every single time, right? From 1 to 2 to 4 to 8, it keeps on doubling. So what we are reminded of is having a squared minus b squared. And the reason for that is because we divide the power by 2 in that case. So instead of doubling, we just divide by 2. And the reason we would be reminded of something like this is if we had something like 2 to the 128 minus 3 to the 128, we would be getting this 2 to the 64th plus 3 to the 64th times 2 to the 64th minus 3 to the 64th. If we kept on expanding that, we would end up getting all the other values along with a 2 minus 3. So all we're missing is 2 minus 3. So can you move to the next slide? If we just suppose I let this be equal to x or s, if we multiplied both sides by 2 minus 3, we would end up just getting 2 plus 3 times 2 minus 3, which is just a plus b times a minus 3, which gives us 2 squared minus 3 squared times 2 squared plus 3 squared, and then all the other terms. So now we see that we again have an a squared minus b squared and an a squared plus b squared. We can just let that be a to the fourth minus b to the fourth. So we have 2 to the fourth minus 3 to the fourth, then times 2 to the fourth plus 3 to the fourth times everything else. This again we can say is just 2 to the 8th minus 3 to the 8th. And we see that if we keep on going on this path, right? So all of the first three, we get 2 to the 8 times 3 minus 3 to the 8th. We can just keep on going on and on until we get 2 to the 128 minus 3 to the 128. So S times 2 minus 3 is equal to 2 to the 128 minus 3 to the 128. Because we're trying to find S, and 2 minus 3 is just negative 1. So I'm just going to go to the top now. 2 times negative 1 equal to this expression, 2 to the 128 minus 3 to the 128. So dividing both sides by negative 1, we just get C, 3 to the 128 minus 2 to the 128 as our answer. So are there any questions for this one?
How did you get 2 to the power of 128 minus 3 to the power of 128?
Yes.
So this is the second last step here, right?
Yeah. So I need. It's okay. So if you see what my first two steps are, I have 2 to the fourth minus 3 to the fourth plus 2 to the fourth plus 3 to the fourth. So now what I can do is, I'm just going to erase this real quick. That is just equal to 2 to the 8th minus 3 to the 8th. If I multiply that with the 2 to the 8th plus 3 to the 8th, I get 2 to the 16th minus 3 to the 16th. Multiplying that to the 2 to the 16th plus 3 to the 16th, I get 2 to the 32 minus 3 to the 32. Multiplying that with 2 to the 32 plus 3 to the 32, I get 2 to the 64th minus 3 to the 64th. Lastly, multiplying that by 2 to the 64th plus 3 to the 64th, I get 2 to the 128 minus 3 to the 128. Yeah, that's a 128. Yeah.
There are questions about repeating the solution. I know you've already done it twice, so I think we should move on in the interests of time because we have several more questions to do. And all those who have asked about repeating the process, is it okay if we will have the recording of the session available to you on YouTube? We'll be putting it on the NSF YouTube channel, and you can look at that again, and it'll be easier actually if you can pause it or look at it several times. I think it will be a little more clear.
So let me just say one thing. If you try multiplying this expression times 2 minus 3 and then see what you get, you'll end up getting the answer. So just try doing that if you have time. Yeah.
Okay, we can move on.
Okay, yeah, move on. I'm just loading the next slide. Just takes a few. Okay. Now Vivek is going to start problem 11.
Okay. So problem 11, can you all hear me?
Yes.
So problem 11. For which of the following integers b is the base b number 2021 base b minus 221 base b not divisible by 3? So first off, there's a way we can simplify this. Now, 2021 base b is the same thing as 2000 base b plus 21 base b. And 221 base b is the same thing as 200 base b and 21 base b. So we can use that as well. So as you can see here, we can cancel out both 21 base b's to get a simpler equation. Now, using the base rules, we know that 2000 base b is just equal to 2 times b to the b cubed, and 200 base b is 2 times b squared. And using that, we can simplify this even further. Now we can simplify this even further by factoring out a factor of 2b squared. So here is what we will use. We have 2b squared times b minus 1, and we need to know for which of the following integers will that expression not result in a number divisible by 3. Now, we can notice that for all of these integers that we're going to try out, if they are going to be divisible by 3, either the term 2b squared or the term b minus 1 must be divisible by 3 for the final expression to be divisible by 3. So we need to find the one number where neither 2b squared nor b minus 1 is divisible by 3. So let's try it out. For 3, we know that 2b squared will be divisible by 3 because 2 times 3 squared is equal to 18. So it does not work. If we try b equals 4, then b minus 1 is equal to 3 because b is 4. So that will also be divisible by 3. So we have to take that out as well. Now let's try 6. Since 6 is a multiple of 3, then 2b squared will also be a multiple of 3. It will be 72. So that will not work either. Now we try d, which is 7. Now 7, if you put 7 into the second part of that expression, you get 7 minus 1, which is 6, and that's also divisible by 3. So now we have one more choice, which is 8. And 8, if you put it into both parts of the expression, it will not be divisible by 3 because 2 times 8 squared is 128 and 8 minus 1 is 7. So because of this, we know that 8 makes the expression not divisible by 3.
Questions. What is base B?
So normally our numbers like we normally use are in base 10, which means that the first digit, the units digit, is the units digit. The second digit is just units digit times 10. So for every 10, it carries over once in the next unit. That's a simple way of putting it. So we can keep doing this for any base and we can get different numbers, even though they can mean the same thing.
How did you get 2b cubed minus 2b squared? I think it's your third step. How did you go from your second step to your third step?
So because of the nature of base numbers, the units digit, if we want to find the full sum of a number in a certain base, the units digit, we multiply that by 1, or b to the power of 0. The second digit, we multiply by b. The third digit, I'm talking about from the right to left. Third digit from the right to left, we multiply by b squared. And the fourth digit, we multiply by b cubed. And using that logic, we get 2b cubed minus 2b squared.
Can you go over the base rule? Can you actually show it on the next page?
Okay. Okay, so I will explain how bases work. So let's say we are instead of using base 10, you're using base 8. So instead of using base 8, base 10, what it means is we have 1. Let's just count from 1 to 10. We have 1, 2, 3, 4, 5.
We cannot see your screen, Vivek.
Oh, Uncle, can you go to the next slide?
Oh, okay.
6, 7. And instead of 8 in base 8, it will be 1, 0. And this may seem confusing, but what this means is that in base 8, if we have 8 in the units digit, it carries over 1 to the next digit. And that's why it is 10 in base 8. I explained it in a simple way. It's a little bit more complicated than that, but yeah.
All right. So are there any resources you would recommend for anyone who wants to learn more about the base rules? Because there are a lot of questions about base rules.
Okay. Khan Academy is a good resource. Just searching up bases in math and what they mean will get a number of good resources for this. And art of problem solving too.
All right. There's another specific question. If you go back to your solution, can you explain how you got from the second to the third step? I think you explained it once, but if you can do that again.
Okay. So this will use the base rules, but what 2000 in base b means is that it's 2 times b cubed plus 0 times b squared plus 0 times b plus 0. So because it's in such a simple way, it's much easier to, instead of having 2000 in base b, it's equal to the same thing as 2 times b cubed. And using the same logic, we can get the same thing for 2b squared.
Doesn't base b normally really mean base 11? People just put it as b.
No, b in this case just can mean any number, just like putting x and y in a line on the coordinate plane. It's just a variable. So we're trying to see in this problem what number in the place of that variable fits our criteria.
Okay, so there's another question. Could you subtract 2000 base b and 200 base b to get 1800 base b, but decide not to do it, as you could find a simpler solution by using 2000 base b and 200 base b through base rules?
So because we don't know the base, we actually cannot do that. Because we've taken base 10, we've known base 10 our entire lives, but that type of subtraction is only for base 10, because when we subtract 200 from 2000, because there's no 2 in the hundreds place, we carry over 1 from the thousands place and add 10 to the hundreds place. But instead of this being base 10, this is base b. So because of that, we don't know how much we can add to the hundreds place. So we just cannot do that. So we have to do what I did in this case.
Okay, I think a number of questions are because some of the students don't know base rules. My suggestion is that Khan Academy is a good resource, or any basic book on algebra will speak about the base rules. The general numbers that we use every day, 1, 2, 3, 4, 5, 6, 68, 78, these are all base 10. The computer bits that we have, we use 10100001, that is base 2. So like that, you can have any number to the base of any number. And I think a good resource would be Khan Academy or Art of Problem Solving books. I think if students can learn the basics, then it'll be easier to solve problems like problem 11.
Should I move on to number 12?
Yes.
Okay. So problem 12, two right circular cones with vertices facing down as shown in the figure below contain the same amount of liquid. The radii of the tops of the liquid surfaces are 3 centimeters and 6 centimeters. Into each cone is dropped a spherical marble of radius 1 centimeter, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid level in the narrow cone to the rise of the liquid level in the wide cone? So what we will first do here is we will compare the volumes of these two cones before the marble is dropped and after the marble is dropped. That way we can calculate the difference. So I'll be making a table in this.
Is there a way, Desi sir, can you zoom in on the question? The words are too small for the audience to see.
Should I continue?
Maybe a little more.
No, it doesn't help at all.
Okay.
So maybe, does it help?
Yes, that's better.
Yeah, but he doesn't have room to write. Yeah.
No, he doesn't have room to write.
I do.
Okay, so let me put it back.
Yeah.
Yeah, go ahead.
Okay, so here I'm making a table where I'm comparing the volumes of this first cone into the second cone. Let me do this here. So for this first cone, I'll just be writing letters instead of the full words. Actually, so this is the radius, and h, this is the height of each cone. And then you can use that to calculate the volume. Just as a reminder, the formula for the volume of a cone is 1/3 pi r squared times h. That's how we'll use this. So now we have the narrow cone, which is this cone, and we have the wide cone, which is the wider cone with a larger radius. So since this is before the marble is placed, we are given the radius, the radii of each cone. Now, instead of having a height, which we don't know, we can use variables. So for this, we can use a variable called h1, and here we can use a variable called h2. H1 refers to this, and h2 refers to this. So we can put h1 in here, the variable for now. And now, using these two, we can calculate the temporary area of these two cones. So here, the volume is 1/3 times pi times r squared, which in this case is 3, so it's 3 squared times the height, h1, which this is equal to 3 pi h1. Now for the second cone, we can use the same exact formula. 1/3 times pi, but instead of the radius being 3, the radius is 6. So we have 6 squared times h2. And here, the simplified version is 12 pi h squared. Did you say something? I guess not. Okay. So now, because we are told that they have the same amount of liquid, you know that 3 pi h1 is equal to 12 pi h2. Now we can cancel terms out, which gives us h1 equals 4h2. So we know before the marble is put in both of the cones, the ratio between the first height and the second height is 4. So these two will come in handy for our second part. So I will make the same thing, the same exact table, but for when the marble is dropped into the thing. Now, do remember that because of similar triangles, if we take the cross section of this cone and we get a triangle of 3 and h1, because of similar triangles, this angle will always stay the same. We know that the ratio of this radius and this height will always stay the same. It's the same thing for this. We have 6 h2. And because this angle is always the same, the ratio of these two will always be the same. This will come in handy later. Well, pretty soon. Yeah.
No one can see the next slide. Can we move to the next slide?
Oh, Uncle, can you move to the next slide?
Sorry. Okay.
Okay, so so what I was talking about by similar triangles, in this triangle, it's poorly drawn, but hopefully you got the idea. In this triangle, which is just from here, this ratio of 3 and h1 will always be the same. 3 over h1 will always be the same because of this angle is the same. This angle is constant here. And by similar triangles, that ratio will always be the same. It will scale together. The same exact thing is for this one because this angle is the same. And by similar triangles, the ratio between h2 and 6 is the same, which we will use that for here. So what we will do is, because these two grow at the same rate, we are not actually going to calculate the new volume using this. We're not going to use this. We're going to say that h1 increases by a factor of x, and since these two are proportional, this radius also increases by x. This height also increases by x. And here we will use y. So let's make the same table. Here we have, instead of 3, we have 3 times x. Instead of the normal height, we have that. Hold on, I'm just getting something up. Here you go. That's not right. It's h1x. And now using these two, we can again calculate this new volume, which is just 1/3 times pi times 9x squared times h1x, which is just equal to the same as before, 3 pi h1 times x cubed instead. You can use the same exact logic for the wide cone. We have 6y, and the height would be h2y. And use the same formula again. We get 1/3 pi 36 y squared times h2 times y, and we get 12 pi h2 times y cubed. Let me Uncle, can you go to the next slide? I just made a third slide for work.
Okay, good.
Okay, so now because let's bring this to the next one. We know that these volumes are still going to be the same because they were the same volume before and they both were added the same radius of marble. So their new volumes will still be equal. So now we can set them equal. And remember, so we have this new equation, and you remember from this first equation here, it looks awfully similar. So because we know that this term and this term are equal, we can actually cancel them out. So now it looks much simpler. X cubed equals y cubed. So x equals y. Now all we need to do is find the difference between the first height, the later height and the first height compared to from both. So now all we need to do is find the change in height 1 divided by the change in height 2. This triangle means delta, which means change. So the final height after the marble was dropped, you can see here was h1x. And the initial height was h1. And the same thing here, we have the final height for 2, the wide one was h2y, and the first height for the wide cone was h2. Now I'm expecting a lot of questions. This may not be crystal clear the first time you hear it, and that's fine. But we can factor this. So now we have this equation. And now remember, since x equals y, you can cancel both of these out. So now we have the ratio of the change is just equal to the ratio. And remember, we have h1 over h2 is equal to 4. And now we know our answer is 4, 2, 1. So it's E. There's probably going to be a lot of questions. That's fine. I'm done.
So the questions are, why is the radius 3x?
Okay,
How did you get h1 is equal to 4h2?
Okay, so Uncle, go to the first slide of the problem.
Yeah, this is the first.
So we calculated the volume of the first, remember this is before x, this is just with h1 and h2 and these two cones, cone and w, narrow and y. And we used this variable we got h1 and this variable we made h2. And because we can calculate the volume of a cone with the radius and the height, we calculated the volume of each cone. We had 3 pi h1 for the narrow cone, and we had 12 pi h2 for the wide cone. And remember, it says they have the same amount of liquid in the very beginning. So because they have the same amount of liquid, they have the same volume. And since they have the same volume, we know that this and this are equal, which is what we did here. And we can cancel out the pi from each and 3 from each, and we get h1 equals 4h2. And divide both sides by h2, and we get h1 divided by h2 is equal to 4. So we know the initial ratio of H1 to H2 is 4.
How did you get x cubed and y cubed?
Okay. In here. So I hope everyone understands where I got x from. It doesn't, it is not an actual number. It just represents the ratio and how much it changed. And because I made it because they have the same rate of change, it would make things easier. So if we all remember, the formula for the volume of a cone is 1/3 pi r squared times h. So we can use the same formula here. So 1/3 is the same, pi is the same, r squared, instead of it just being 9, like the first graph, like the first table, it is now 9x squared, because 3x squared, 3x, if you square the entire thing, is 9x squared. So that's where that is. There are 2 of the x's come from. And for height, instead of just being h1, it is now h1x. So there's 3 factors of x that it increases by. That's how we get the y cubed too.
Can't you just do the ratio of the area of both bases to solve the problem?
You can actually. This is just much more complicated way of doing it. But you can say that. You can say that the ratio, because the volume is always the same, and the volume added to both is the same, you know that you can use that the area of the top is 4 times larger in the second, so the area of the height will be 4 times larger in the first. Yeah, you can do that. That's another way of solving it.
All right.
That was a good question.
Let me see.
These are all good questions, by the way.
Can you go more in depth on the x and y concept with the similar triangles again?
Okay. What slide? Slide 4. I'm going to make a new slide, actually, Uncle. So I am now on slide 6. So can you go to there, please? There you go. So the concept of similar triangles means that, let's say we have this triangle. We have A, B, C, B prime, and C prime. And let's say this angle is just any number. Let's say it's 30. It doesn't really matter. All this is saying is that the ratio of this to this is the same exact ratio as this whole full thing to this. That's all it's saying. So all I was doing was saying that what x means in my problem was this divided by this. And because these are proportional, this divided by this would be still x. So we can use that. Uncle, please go to slide 4. Yeah, so we can use this same ratio on both the radius and the height to try to, make things go along further. Does that answer your question?
There is another question which I didn't quite understand. Why was adding the marble important if the ratio would be the same?
Well, how do I talk about this? The adding the marble was important, but I mean, in the end, the ratio of H1 to H2 ended up being the same. But the reason we were going through this whole problem is because we didn't know that. We were looking to prove it. We were trying to make sure that the ratio was the same. And that's why we had to figure out that x is equal to y, the ratio of how much they increased by was the same, and we use that to prove that, okay, it was the same ratio.
What is C prime and B prime?
So in geometry, Uncle, can you go to slide 6? So in geometry, when if you have a triangle, A, B, and C, sometimes a question will say, okay, extend this line a little bit, extend that line a little bit, so you get a larger triangle. So instead of just calling it something like D or E, people try to show that, okay, that it's just an extension of this point. So they call it, instead of a new letter, they just call it B prime and C prime. That's all it means.
There's a question related to the marble question earlier, and that is, would the ratio be the same no matter the size of the marble?
Yes, the ratio would be the same no matter the size of the marble. We didn't even need the size of the marble. We didn't use that anywhere because it doesn't matter. Because as long as the same amount of volume gets added to both cones, it doesn't matter. Because the end volume will be the same for both.
Couldn't you just use the original ratio of the original heights, because ratios are proportionate and they would remain the same?
Yes, but we just wanted to prove that it was. Sometimes in problems like these, adding something like an extra marble can ruin the ratios. But yeah, I mean, you can use reasoning to do that, but this is just a proof work of that reasoning. It was just that reasoning put on paper. But yes, you can.
Yes, you can move on to the next problem.
Okay. Problem 13. Uncle, are you on the slide? Yes, you are.
Yeah.
Disregard this picture. I tried putting it before. It's not very good. So problem 13. What is the volume of tetrahedron ABCD? By the way, a tetrahedron is a 3D figure, and it has 4 sides, and every single side is a triangle. Actually, I will bring back that original picture. Let me see. This is a tetrahedron. It has 4 triangles, 1, 2, 1 on the bottom and 1 on the back. And so that's what a tetrahedron. One point is A, B, C, D. The thing is, this has different dimensions than our problem, so it might confuse people. So I will remove it for now. Problem 13. What is the volume of tetrahedron ABCD with edge lengths AB equals 2, AC equals 3, AD equals 4, BC equals the square root of 13, BD equals the 2 root 5, and CD equals 5. So we are given all the side lengths. So using this, we can draw a tetrahedron. So I hope everyone understands that this is a 3D figure, and this is behind the this triangle. This point is A, this point is B, this point is C, this point is D. So now what we can first do is label every single one of these points. So we know AB is 2, AC is 3, AD is 4, BC is the square root of 13, BD is 2 times the square root of 5, and CD is 5. Now, we can notice that these are all right triangles. We know that 2 squared plus 3 squared equals 13 squared by the Pythagorean theorem. 2 squared plus 4 squared is equal to 2 root 5 squared. So we know this is a right angle. And we know that 3 squared plus 4 squared equals 5 squared, the classic Pythagorean triple. So we know that these are all right triangles. So now all we need to do to find the area of this entire thing, this entire tetrahedron, is treat it like a pyramid, because now we have a base and we have a straight height. So we could rather calculate it like that. So all we need to do to calculate the area of this pyramid is 1/3 times base times height. So what we will do is count this triangle of ADC as the base and this AB as the height. So all we need to do now is find the area of this ADC triangle, which, because it's a right triangle, it's just 3 times 4 minus 2, which is equal to 6. So we have 1/3 times 6 times height. And we know height is just AB, and so height equals 2. So the final answer is 1/3 times 6 times 2. So, and that is equal to 4. Can you read the questions? No.
How did you know it was a right triangle?
So we use the Pythagorean theorem because we know that the Pythagorean theorem works if and only if the a squared plus b squared equals the hypotenuse c squared, and which means that if it's a right triangle, the theorem always works, and if the theorem works, you know it's always a right triangle. So because the triangle AB, BC, and CA fits that Pythagorean theorem with 2, 3, and 13, because 2 squared plus 3 squared equals root 13 squared, because 4 plus 9 equals 13. We know that this is a right triangle. Now, using the same reasoning, you can use the same for every of the other 2 triangles, because 2 squared plus 4 squared is, this is root 20, so 4 plus 16 is 20. So we know that this squared plus this squared is that squared. You know it's a right triangle. And 3, 4, 5 is the most commonly known right triangle, because 3 squared plus 4 squared equal to 5 squared. 9 plus 16 is equal to 25. That's how I knew.
There's a question about what you wrote at the bottom. 34 divided by something is equal to 6.
Okay, so I meant to put a dot here, which means because I was calculating the area of this base ADC, I think the dot just did not register, but I was calculating the area of that using base times height over 2, and I was just saying this was 3 was the base and 4 was the height, and I used that to calculate this base, which I needed for the final calculation.
Why is the height 2 in this 3D figure?
Okay, well, we could have chosen any like triangle of these 3 right triangles and any of the opposite heights. It would have resulted in the same thing either way. But because we chose this 3, 4, 5 triangle, the height of this entire thing will be here. Because let's say if this is a 3D figure that you have that you're holding in your hand, if we put this on a table, this will be the height. So it is 2.
There's a general question. How would you approach this problem when you first see it?
That is a good question. So, of course, I didn't know exactly what to do when I saw this problem, but over many problems that you do, you start to grow an intuition on what things might work, what strategies might work. Obviously, the moment you see a question, you won't always know exactly what to do, but especially with the geometry things, try to find right triangles because they make things a lot easier. Like this, they have special properties that will help you. So just whenever you see any possible triangle, just check that if it's a right triangle, because it will help you.
Can you go over why the base is ABC?
ADC, you mean? Because ADC is the base.
AABC. Well, it's actually ADC, it's the base, so maybe that's...
Maybe they just had that confused. Yeah, so the base is ADC. So this triangle here, that is the base we are using, the 3, 4, 5 triangle. So we calculate the area of that triangle, and we know the height is 2, and using that we can find the area.
Then there's some confusion about what you wrote at the right bottom.
Okay.
1/3 times 6?
Times 2.
Or
So
is it times 2?
yeah. I have to, sorry about that. I have to make the dots more clear. So because the formula is 1/3 times base times height, I was filling that in gradually as I found out that the base was 6. So then I just needed to find h. So it was 1/3 times 6 times h. And then finally I found h was 2. So the formula I had to figure out was 1/3 times 6 times 2, which I found was equal to 4. Sorry about that.
Got it. So then there is a more basic question around, could you go over it starting from 1/3 base height? So maybe you can just quickly run through the solution once more real quick.
Okay, I'll do it really quick because it's not 30. But so we know we have a tetrahedron here, but you can also use it as the formula for finding the area of a pyramid. And we can do this because we have a clear height and we have a clear base. And we don't have to use this triangle ADC. You don't have to use that, but we could have used ABC and used this as the height, or ADB and AC as the height. It doesn't really matter, I just chose this. So because the formula is 1/3 times base times height, we had 1/3. We need to find the area of this triangle because that was the base, and we needed to multiply that by 2 because that was the height. That's how we use the formula.
Yeah, we can move to the next question.
Okay. So problem 14. All the roots of the polynomial z to the power of 6 minus 10 times z to the power of 5 plus a times z to the power of 4 plus b times z to the power of 3 plus c times z to the power of 2 plus d times...
Can you move to the next slide?
Uncle.
Next page.
Okay, I will repeat myself. Problem 14. All the roots of the polynomial that on the screen are positive integers, possibly repeated. What is the value of b? So in case a lot of you may not be familiar with what the Vieta's formulas are, basically you can look at these coefficients and tell certain traits about the roots. So using the Vieta's formulas tells you that the product of the roots is this last number. So we know the product of, let me just use text actually. The product of roots equals 16. And what the Vieta's formula also tells you is that the sum of the roots is 10. It may not, if it's not clear right away, I'm not going to go over the full Vieta's formulas, but the product of the roots, again, is just this constant. And the sum of the roots is negative times this coefficient divided by this coefficient. This is 1, and this is negative 10. So negative 10 over 1 is 10. So because we know that because it's z to the power of 6, we know that there are 6 roots. All of them are integers, and their product is 16, and their sum is 10. Now, you can do a little bit of just playing around, trying to see what combination of numbers would work, would this combination of numbers work, and so on. But if you have done many problems like this, and you've done a lot of math, and maybe you have the intuition to see that, okay, the numbers are 1, 1, 2, 2, 2, 2. And you can either get this either by, some people will see it right away that this could be it, and some people will have to, experiment. Like say, okay, could it be this and this? No, this doesn't work. Let's try it like that. You can do that also, and eventually you will pretty quickly, hopefully, get to this. So because we know that these are the roots, we know that the equation is z minus 1 squared, because there are two roots of it, times z minus 2 squared. I'll put a line through the z's because it may be hard to differentiate. So we have this, and we can expand this into z squared minus 2z plus 1 times, I'll carry over into the next line, but these are the same part of the same one. We need to expand z minus 2 squared, which is z to the power of 4 minus 8 times z to the power of 3 plus 24 z to the power of 2 minus 32z plus 16. So all we need to do is expand this and find b, but we don't need to expand the entire equation because we don't need to find the entire equation. All we need to find is the coefficient of z cubed. So how can we find this coefficient of z cubed? You can multiply z squared and 24, not that, z squared and negative 32z. And so now let's try to solve for b. We know that this is negative 32z cubed. You can also multiply negative 2z by 24z squared because this coefficient adds to 3 again. So now we have minus 48z cubed. And then we can multiply this 1 by negative 8z cubed because again, it multiplies to a coefficient to a z cubed. So you have minus 8z cubed. So we know bz cubed is equal to, we can sum these up and we get negative 88z cubed. And now we know that this is the coefficient of this. So b equals negative 88. Sorry if it's mushed up in the corner. I'll write it here. Questions?
So why is it z minus 2 whole square?
Oh, that is my mistake. I meant 2 to the 4th. I completed the problem correctly. I just wrote that one number wrong. Thank you for correcting.
So a question is, what does it mean when you put a variable below a number?
Below a number.
Not sure what is being asked here.
I'm not sure what that question.
Yeah, I'll check. Maybe we can move to something next one.
The next question.
Yeah. Okay. This one. It's a degree 6 polynomial, so that is why there are 6 real roots, right?
Yeah.
A quick reminder that we have already exceeded 2 hours, so let's keep moving.
I will try to, 15 can be solved fairly quickly, so we can do that. I will start number 15. Uncle, can you go to slide 11? Okay, I will try to do this as quickly as I can. Values for A, B, C, and D are to be selected from the set of 1, 2, 3, 4, 5, and 6 without replacement. So no two letters have the same value. How many ways are there to make it so that such choices, so that the two curves y equals ax squared plus b and y equals cx squared plus d intersect? The order in which the curves are listed does not matter. For example, the choices a equals 3, b equals 2, c equals 4, and d equals 1 is considered the same as choices a equals 4, b equals 1, c equals 3, and d equals 2. So the first thing we can do is we can, since we know that y equals ax plus b, we know here, and y equals cx squared plus d, we can set them equal to each other. So we have ax squared, ax squared plus b equals cx squared plus d. So what we can do now is get the like terms on the same side because we're trying to simplify this. And so we can subtract cx squared from both sides and b from both sides. So now we have ax squared minus cx squared equals d minus b. And we can factor out the x squared. So now we have x squared a minus c equals d minus b. So we can take the a minus c, divide both sides by a minus c, and now we have x squared on one side, d minus b divided by a minus c. Now, there is this inequality called the trivial inequality, which means that any number squared is greater than or equal to 0. So because this is equal to x squared, we know that this is greater than or equal to 0. Now, because of that, we know that d minus b and a minus c are either both negative or both positive. Okay, first, let's start constructing the number of ways you can do this. So first, it's 6 choose 2, because we're choosing a and c, times 4 choose 2, so which is d and b. And also now we have two more options because they both can be negative or they both can be positive. So for example, let's take this. Actually, no, let's take that a and c in no specific order are, let's say, 1 and 3. Okay, we don't know which either a or c is 1 or a or c is 3. All we know is that 1 and 3 correspond to a and c without order. Now we know b, d is 6 and let's say, let's not say 6, let's say, sorry, there is a fire truck outside my house. So let's say that b and d is 5 or 2 without any order. So we can either construct this such that a minus c is negative and b minus d is negative, or d minus b is positive and a minus c is positive. Hopefully it's clear why there are two ways this can happen. So I'll keep this. So now it looks like this is all we need to construct the number of ways, but we also have to remember that a and c and b and d are not distinct. The curves are not distinct, which means that we have to cut our number of ways that we can do this in half because we are double counting. So we have, do the dot, 1 divided by 2, and this is what we need at this point. So 6 choose 2 is 15. 4 choose 2 is 6. 2 times 1/2. So the answer is 90.
Question. The question is, I understand the trivial inequality, but after that, after you applied that, could you explain again?
Okay, so since we know that D minus B divided by A minus C is greater than or equal to 0, that means that if and D minus B is negative and A minus C is positive, then we know that x squared is negative, which is obviously not possible. So we know that there are two cases. Case one is that both A minus C and D minus B are both positive. The second case is that both D minus B and A minus C are both negative, because these are the only two ways that D minus B divided by A minus C will be greater than or equal to 0. So that's where we get this 2 after the 4 choose 2 in the bottom right. We get the first 2 because those are the two ways we can construct AC and BD. And we just get the 1/2 because all we need to do, we're double counting for every single case, because AC and BD, their order does not matter.
Okay, that was the other question. Why is it multiplied by half?
Okay.
How did you get ax square plus b is equal to x square plus 1?
Okay, so I see the confusion. So in ax squared plus b, this is actually cx squared plus d. So this is a c here, and that is a d. Yeah, it may have looked like those were in parentheses, but it was a c and d.
All right. You put z at the bottom right corner of 8 in the formula. Maybe the previous, no.
This is a 2.
Yeah, that should be a 2. Yes.
Yeah.
All right. Okay, I think we, that's the end of the questions. Desi sir, I think we can do the polls now.
Yeah, we did the polls at the beginning.
Okay. So did we announce the, yeah.
Yeah, please go ahead and announce the.
There's a second session. So there's a second session which will deal with problems 16 through 25. And that second session is going to be held on Sunday, that is day after tomorrow, February 28th from 4:30 to 6:30 Eastern time. So anyone who's interested, obviously the problems will be much, they will increase in difficulty. So, from problem 15 onwards, it will be increasing in difficulty. So anyone who's interested in understanding how to solve those challenging problems, please sign up for that webinar as well. We have 3 panelists, and also we have a guest speaker who has been a 2-time national math counts champion, Luke Robitaille, who is also coming to talk to the audience as a guest speaker. So thank you everybody for staying on so patiently. If there are any other questions, maybe Vivek can take them, or the organizers can take them as well. Krish too.
Yeah, thank you everybody for attending.
Yeah,
so is there any?
There is one question.
Go ahead.
One student asked a question. Okay, which problem was this? So this was the problem on the the 2 cones.
Okay.
If you can go back to that, I think it was number 11 or 12. I think it was number 12.
It was number 12.
Yes, if you can just go back to that.
Okay.
Let's go to number 12.
Hang on 1 second. For problem number 12.
Yes, so yes, here. So the question was, if you already found out that the ratio was 4:1, why did you like continue?
So I continued because that first initial 4:1 ratio was the ratio in the very beginning before the marble was dropped. And then I had to find out that the change from that original, the final one to the original one was using the same ratio. Again, using reasoning, you can realize that the ratio will stay the same. But for this, I'm trying to show my work, I'm trying to show the regular way to do it and the proof way to do it, the rigorous way to do it.
Okay. And then there are two general questions. One is, how much time should we spend on the first 10 questions in this AMC exam?
So the first 5 questions, especially questions 1, 2, and 3, you can solve them in a minute, maybe, because especially the first one was just computation. You should try to finish the first 10 maybe in around 25 minutes, 30 minutes. Sometimes even less, maybe even 15 if you're quick. But normally what I try to do when I take the test is I try to take 1 minute each for the first 5, 2 minutes each for the next 5, 3 minutes each for the next 5, and 4 and 5, and so on. But again, anytime works for you. I would say do mock exams and see what strategy works for you. You can try any possible strategy you want and see which one works best for you. But that, I said, what works best for me.
There's one other question. How are you guys so smart? So maybe you can both, Krish and Vivek, just take the audience through your personal journeys.
Chris, you want to speak first?
Sure. So I started math at an early age, around 5, 6. I just started to learn math. Not learn it, but like play fun math games, and that got me more and more interested in it. And in middle school, I started to do more in math, like get more involved. There was the math counts competition, which I started to prepare for, and it just engrossed me, and I started to love math. And I put my effort in trying to become a better mathematician, and I guess that's where I am now.
For me, I did a little bit of math. I really didn't like it, but in 3rd grade, I remember there was this one competition, this local competition for my school and a few neighboring schools, and I didn't think I would do very well, but I ended up doing pretty well. So then I started suddenly getting very interested in it because I felt like I was all right at it at the time, and ever since 3rd grade, I've just kept working and improving. Haven't worked as much as I had liked sometimes, but that's generally my journey. I've especially like a few years ago, I was in an environment in a school where it was competitive, so like it pushed me to work more. But
Yeah, I want you to tell us that how participating in NSF contests helped you or did not help you at all. And did it have any effect?
You want to go first, Vivek?
Okay, yeah. So I've been doing NSF even before 3rd grade, almost as early as I can remember, because I know my mom was a volunteer there, so she brought me along. I would do all the B's, geography B, spelling B, math B, science B, everything. I've pretty much grown up with it, and I've gone to nationals a couple of times because I did pretty well, but I think it really did help me improve my math skills.
So I only started NSF in 5th grade. That's when I learned about it. And my first year, I did good, but I didn't do as well as I thought I would. So I wanted to just keep on improving and improving. And other than math counts, there wasn't really any major competition. So NSF became really helpful for me because I could use my skills in a competitive environment because my school wasn't really that competitive. And it really just helped me like motivate myself and train myself to become better and better.
So there's another question. How many questions do you expect us to know by our grades? So I don't know what grade this student is in, but say, for example, if you are a 7th grader, how many questions should you be expected to be able to do in this exam, in this AMC 10 exam?
This is a really hard question, not because like it's hard, it's like changes a lot, just because it really depends on the person. Let's say if you're the smartest 7th grader in like the history of the world, you'd want a higher score than a regular 7th grader. It really just depends where you are. And first, I would just make sure that you're constantly improving year after year on the AMCs. That's constantly taking mock exams to see where your progress is, and just make sure you keep improving. And eventually, if you keep going up and up and up, you'll reach the top. Chris, you want to say?
Yeah, Krish, do you want to say anything?
Well, not really. So as Vivek said, just it depends on what your level is and how much you want to, how good do you want to be. If your goal is to like, let's say, make Amy in 9th grade, then you should be able to solve about 10 questions in 7th grade and just keep on going. But it just depends really on who you are and how much do you care about this.
And finally, are there resources to learn these topics?
The Art of Problem Solving books and that whole system, their forums, is really, really good, and so many people use it for a good reason. They have books for almost everything: pre-calculus, intermediate algebra, intermediate counting and probability, number theory, beginner levels of everything, intermediate levels of everything. Including the forums, two people post handouts that help you, informational handouts saying, oh, here's a theorem. This handout will help you with that theorem. And really, if you know like where to look, if you are smart with everywhere you're looking for information, especially on just art of problem solving, you will find almost everything you need.
Yeah, so one other resource that is used, and art of problem solving is really good, but if you just want more and you're not at like a really high level yet, Math Counts, their website, they have a few resources that is also good. It's, I'd say, a bit lower level than art of problem solving. So if you're not at the highest level yet or not at a intermediate level, then you should also look at the Math Counts website.
Yeah, I agree.
Thank you, guys. You guys are really fascinating. We are hitting the 2.5 hour mark, and
there's this one last question which is important,
okay,
and I
go ahead.
like to ask, and that is, one student says, we have not heard of this test in our schools in Ohio. And so I do know that many schools don't necessarily subscribe to this whole AMC competition. So can both of you speak about what can such students do?
So there are two things you can do. One is, if your school doesn't administer it, one, you can try to convince the math head in your school, or try to rile up interest with your friends or people like that, and come to the teachers and all that together saying like, we want to take this test, and hopefully they will be like, okay, there's a lot of people interested, we will subscribe. But if that doesn't work, you can also take it at external places. Like I took it at a local RSM that was close to my school. RSM's a math learning place, and they administer the AMC. So I took it there. And your school usually only administers either the AMC 10A or B. So if you want to take both, you will have to go outside for at least one of them. So that's what I did. Chris?
And so what I did is they offered only one, the AMC 10A. So what I did is there's another school in my area. It's a little bit far, but not too far. So because I wanted to take the 10B, I went there. So what you could do, as Vivek said, is go to an external place, math clubs, maybe another school, or an AOPS site, art of problem solving site. They have some, I don't know exactly where, but it's on the website if you want to check.
And this just goes for any other questions you may have about the good questions like these. Just if you have anything else like this, just make an art of problem solving account and post a question on their forums. There's hundreds, thousands people that are willing to help you. answer your questions.
All right, that's it.
Hey, thank you, everybody. You guys are definitely geniuses. But wish you all the luck the rest of your life. You are just starting your educational careers.